everyone, and welcome to another math tutorial. This third video in chapter 1 is titled Midpoint and Distance Formulas. So we're going to look at how to find the midpoint of a segment and also the distance of a segment on a coordinate plane, and also just what we mean by midpoint. And we'll talk about bisectors as well. So some vocabulary, some formulas, kind of a little bit of mix of everything in this particular section. Okay, our first definition is that of midpoint. A midpoint is a point that divides a segment into two congruent segments. Okay, so here we see point M. It's in the middle of points A and B on segment AB. And then you see these congruent tick marks, right? So I know that point M is the midpoint. Point M is the midpoint of segment AB because AM is congruent to BM. Okay, so that's what this definition says, and it's illustrated here on the picture. Now, related to a midpoint is that of a segment bisector. A bisector can be any of a point, ray, line, or segment. Essentially anything that will intersect a segment at its midpoint. Okay, so here in this picture you can see again this point M is the midpoint, and then you see that there's a line right there at the midpoint. So this line is what we call the bisector of segment AB. Okay, bisector essentially means that it's cutting it in half. All right, our first example problem is to identify the segment bisector and then find AB. The segment bisector, so to find this, basically I need to know what is it that is intersecting the line at the midpoint M. And right here at point M, I see this figure. That figure is a ray. So the segment bisector is ray MC. Next we want to find AB. And AB, notation wise, that's just the length of AB. How long is it from point A to point B? Well, these tick marks right here tell me that it's the same length from A to M as it is from M to B. So if this is 8, this is 8, therefore AB has to be 8 plus 8, which is 16. Okay, second example problem, same exact directions. The segment bisector, right here at point M, we see this line. So the line is our segment bisector. There are no 2 points. There's just this indication out there that it should be called line L. So that's our segment bisector. And then the length of this segment AB, again, I see the tick marks here, meaning that they're the same. So if it's 26 on this side, it's 26 on this side. And so AB is equal to 26 plus 26, which is 52. Okay, same kind of directions on this particular slide. We're first asked to identify the segment bisector. So what do we see that intersects the segment at the midpoint? Here's the midpoint M. And right there I see a ray. So the segment bisector is ray MT. Next I'm going to try and find EF. Now since ray MT is the bisector, that means that this side and this side are the same. So we can say that 6x is equal to 2x plus 4. If I subtract 2x from both sides, it gives me 4x equals 4. So divide both sides by 4. And 4 divided by 4 is 1. Now I'm not asked to find the value of x. I am asked to find the value of EF. Well, with the value of x being found, I can now substitute that in. So here, if x is 1, we get 6 times 1, which is 6. Here, if x is 1, we get 2 times 1, plus 4, which is 2 plus 4, which is also 6. It's a great check step that these two are the same value because they should be the same. And so EF, to finish this problem, EF is equal to 6 plus 6, which is 12. Okay, here's another example problem just like the last one. So what I would suggest if you're watching this from home is that you go ahead and maybe pause the video, attempt this problem on your own, and then when you've got a solution, you can press play and maybe even just fast forward to the answer and see if you have it right. And if not, then you can go back and watch this piece. So here we go, identify the segment bisector. Okay, so what do we see at the middle of this line or intersecting the line at M? And what I see is line M. Next I want to find EF. So to find EF, I'm going to take these two pieces and set them equal to each other because they're congruent. So 7x minus 3 has to equal x plus 15. I want this x to come to this side, so I'm going to subtract x. I want this minus 3 to come over to this side, so I'm going to add it. So 7 minus 1 gives me 6x, and 15 plus 3 gives me 18, and 18 divided by 6 gives me 3. Okay, so I've got the value of x. Now I need to complete the problem by finding the length of segment EF. So if x is 3, then this piece is 3 plus 15, which is 18. Now this piece over here should also be 18. I would not assume that it is because our math over here might have been wrong, but I would go ahead and plug this in here, make sure that it is. So 7 times 3 minus 3 is 21 minus 3, which is 18. So they have checked out, both sides are the same. So the length of EF is going to be 18 plus 18, which is 36. Okay, next thing we're going to look at is midpoint formula. Now there is a lot going on in this diagram right here, so you might need to at some point pause this particular slide and just kind of take a look at that and kind of let that all sink in. But what we're going to do with midpoint formula is how do we find the middle of a line segment if that line segment is plotted in a coordinate plane, an XY coordinate plane. And so what the formula, or I guess definition here, formula, what it says is that the coordinates of the midpoint of a segment are the averages of the X and the Y coordinates, right? So let's recall, how do we find average, right? You find an average by adding all the numbers up and then dividing by how many numbers you had. And so when I look at this midpoint formula, which is right here, look at what we're doing. To find the middle of points A, B, what I'm going to do is take the X coordinates of the endpoints and I'm going to add those together, and I'm going to divide by 2 because there were 2 numbers that added together. To find the Y coordinate, I'm going to take the Y values, I'm going to add them together and divide by 2. So all I'm doing is finding the average of the 2 X coordinates, and I'm finding the average of the 2 Y coordinates. That's all there is to it. Okay, so we're going to do a problem where we utilize that formula, and then I think I'm also going to show you a problem worked out just a little bit differently. Okay, so you have a couple different ways to do this. Okay, the example problem says to graph the segment whose endpoints are given, find the midpoint of that segment. So I've got these points P and Q. Point P is at -4, 3. Q is at 0, 5. So I've got this segment right here. And I want to find the middle. And midpoint formula, again, says that, let's do it over here. To find the midpoint, I'm going to add the x's. So the x's are these numbers. And since there were 2 of those, I'm going to divide by 2. That's how I do the average. Now I'm going to do the same thing to the y values. So I'm going to add 3 and 5. I'm going to divide by 2. So our midpoint is going to be -4 plus 0 is -4. Divide that by 2. 3 plus 5 is 8. Divide that by 2. So the midpoint m is at -2, 4. And -2, 4 is right there. Okay, so there's an example problem finding midpoint with this actual formula in use, where I'm finding the averages of the x's and the y's. Okay, the next example problem, same directions. I want to find the midpoint of the segment. I'm going to show you how to do this a little bit differently. The nice thing about the formula is I could do the formula without a graph, right? Formula just needs me to plug in numbers, and I can work through that out and I can find the midpoint. But if we're going to go through the trouble of drawing this out on the graph, I'm going to show you a second way to do this, just utilizing the graph that we have created. Okay, so I'm going to start at -2, 7. There's point P. It's right there. And then point Q is at 10, -3. And there's our line segment. And since these points are really far apart, it might be nice to just go and use a ruler to connect them. So we have a nice straight line segment there. Okay, so here's my second method for doing this. And again, since I'm on a graph, I'm just going to use the graph. And this technique, all it requires is counting. Okay, I'm going to count how far away is point P and point Q horizontally, and how far apart are they vertically. Okay, so to get from P to Q, I have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. Okay, so that's pretty easy. We're just counting. To get from P to Q vertically, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Okay, so 12 and 10 to get from end to end. Now, if I want to find the middle, all I have to do is divide these lengths by 2. Cut them in half. So 6 and 5. So what I'm going to do to find the middle is I am going to go, instead of over 12, I'm going to go over 6. 1, 2, 3, 4, 5, 6. Okay, so I'm going to go to right there. And then vertically, I have to go down 5. 1, 2, 3, 4, 5. There's the middle. If I go 6 and 5, and then another 6 and 5, those two 6s make the 12, these two 5s make the 10, but I found the middle. So the middle is at the coordinate point 4, 2. Okay, so there's an alternative way to find the midpoint that we can just count our way there. And this counting technique is going to be very applicable towards other things that we're going to do in this course. So I really like this, especially if we've already put it on the graph anyway. Might as well use that. Okay, here's one final example of midpoint. It says that the midpoint M and one endpoint of segment JK are given. Find the other endpoint. So this one's a little bit different. We're not finding the midpoint. We have the midpoint already. So let's plot out what we have. J is at 7, 2. The midpoint M is at 1, -2. And I want to find where is K. Well, so if my segment so far looks like this, right? Now I know this is one endpoint. This is the middle. The other endpoint has to be down here somewhere. Okay. question is, where is it? Now, I like personally this counting approach, so I'm just going to go ahead and do that. To get from J to M, I went down 4 units, and I'm going to go across horizontally 1, 2, 3, 4, 5, 6 units. So to get from one endpoint to the middle, it's down 4 over 6. I'm going to do that again. Go down 4 more over 6. And that should be my other endpoint. Right there. Okay, so that completes the line segment. That's point K. So point K is at, looks like -5, -6. Okay. Now, let's say you didn't want to do that on a graph. Let's say you wanted to use the formula. I want to show just kind of real quick how we could do that with the formula. So I'm going to do this just in pieces, right? The midpoint formula. So let's say I want to find the midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. So let's say that this coordinate j is my x1, y1, and this coordinate k is my x2, y2, right? So I'm just going to work on this one. I'm going to ignore the y just because you can do it the same way. But let's just show you how to find the x value, right? The x1 is the j value, which is 7. x2, I don't know. It wasn't given to me. Divided by 2. That should equal the x coordinate of the midpoint, which I know should be 1. Okay. So now I'm just going to solve this algebraically for the x2. I can multiply both sides by 2. We get 7 plus x2 equals 2. If I subtract 7 from both sides, we get x2 equals -5, which, sure enough, it was -5. So I can do the same exact process to find the y2 value. So there is an algebraic way to do this where you don't have to have a graph. I, again, think it's visually more appealing. I think it's easier to just count and count again on a graph, especially if I'm taking the trouble to put it on the graph. I'm just going to go ahead and do it that way. But you've got a couple of ways that you can approach this type of problem. All right, the next thing we want to talk about is distance formula. We have done distance between 2 points on a coordinate plane when the line segment was just horizontal or vertical. But I told you in the last video that we were going to look at how do we do it if the line is slanted, if it's diagonal, right? And so that's really what we're looking at right now. Is how do you find the distance between 2 points or the length of a segment where you just can't count the boxes on the graph, okay? And so there's 2 ways to do this. One is what we call the distance formula, and that distance formula is typed up right here. And essentially the distance formula, again, you've got 2 endpoints. You've got this point here, you've got this point here of line segment AB. You're going to take the x coordinates. Well, it doesn't really matter the order. I arrowed them to the wrong spot. But you're going to subtract the x coordinates and then square that quantity. Because we're squaring it, doesn't matter the order here. But you're going to subtract those and square it. And you're going to do the exact same thing to the y coordinates of the points and square it. Add that and then the square root of the whole thing. Okay? That's our distance formula. I'm going to show you how to use that formula exactly. I think it's really nice. Again, like midpoint formula, if you don't have the picture of a graph, but all you have are numbers, and you can just put all those numbers into the spots and then compute it, this formula works really, really good. The other way that I'm going to show you, something you're all probably familiar with, so we're not really teaching this today, but we're going to use it, is Pythagorean's theorem. Now, Pythagorean's theorem is basically just distance formula. I'm going to show you that when we work through it with Pythagorean's theorem. So I'm going to show you one example, but I'm going to do it two different ways. I'm going to do it with this, and I'm going to do it with this. And then you can decide which you like better. Okay, the directions are to find the distance between the 2 points. So we have point E, which is at 3, 7. Point F, which is at 6, 5. And I want to know how long is that segment. What's the distance between them? And again, there is a distance formula. The distance formula would give me the length of EF. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. Again, the nice thing about the formula is I don't need to see a picture, right? All I need to see are numbers, and these numbers are going to plug into the correct spots over here. Okay. So with my formula, this point right here could be x1, y1. This point could be x2, y2. And all we're going to do is put those numbers into the right spots. Okay, so x2 is labeled as 6 minus x1, which is labeled as 3. Square that. y2 is 5. y1 is 7. Square that. So 6 minus 3 is 3. That needs to be squared. 5 minus 7 is negative 2. That's going to be squared. 3 squared is 9. Negative 2 squared is 4. So we get the square root of 9 plus 4, which is the square root of 13. So that's EF. Now, square root of 13, if you type that into a calculator, you're going to get a decimal, which is why I just left it as the square root of 13. But if you want to type that into a calculator and get an approximation, you certainly can. The square root of 13 is approximately 3.6. So you all have to decide, depending on how the answer is to be reported, do you leave it like this or do you leave it like this, okay? Now I'm going to show you, I'm going to bring out a brand new slide, and I want to show you the exact same problem, but I'm going to show you a different approach than this formula. And then with two approaches that'll yield the same exact answer, you can decide which one you like better. Okay, so here we go. Same example problem. I'm going to plot these points. Point E is at 3, 7. Point F is still at 6, 5. There's our line segment. Okay, so again, I'm going to use Pythagorean's theorem this time. And Pythagorean's theorem is simply a squared plus b squared equals c squared. Now the A and the B are legs of a right triangle, and I have a segment. I don't have a right triangle. So what I'm going to do is I'm going to build myself a triangle either above or below that segment. So there's my right angle, my right triangle. Now the lengths of these lines I can just count. Coming straight down, that's 2. Going straight across, that's 3. And so in either order, it doesn't matter. One of these is 2, so the A could be 2, and I'd have 2 squared. The B could be 3, so 3 squared equals c squared, and the c, of course, is the hypotenuse. So 2 squared is 4, 3 squared is 9, that's c squared. 4 plus 9 is 13. And so to get rid of the square, we're going to square root both sides. And we've got c equals the square root of 13. And of course, c is the length of segment EF. Okay, so same exact answer. I just did it a little bit differently. But you can see how these are essentially the same exact thing, right? I could up here, I could square root as my first step. And then we have c equals the square root of a squared plus b squared. And of course, a could be the x2 minus x1. B could be the y2 minus y1. And you can see how this formula is the exact same idea as distance formula. I think it just matters what do you want to memorize? Do you want to memorize distance formula? If not, you can certainly just use Pythagorean's theorem and it's the exact same thing. Okay, so it's up to you how to proceed with these types of problems. Okay, one more example problem. This one says that your school is 4 miles east and 1 mile south of your house. Let's put our house right there at the origin. Okay, so the school is 4 miles east and 1 mile south of your house. I'm going to label that S for school. Next sentence says that a recycling center is 2 miles east and 3 miles north of your house. 2 miles east, 3 miles north, that's a recycling center. Question is, how far apart are the school and the recycling center? So how far apart are these two pieces? What is that length? Okay. I am personally a fan of doing Pythagorean's theorem just because I think it's a little faster. I think it's a little bit easier. And I know Pythagorean's theorem really well. So let's just build ourselves a triangle underneath here. It's 4 on one side, 2 on the other. So Pythagorean's theorem would be 4 squared plus 2 squared equals c squared. So that's 16 plus 4 equals c squared, which is 20. And then to get c by itself, we want the square root of 20. Now, since we're talking about miles and distance, how far apart are these two things, it would make sense for me to just go ahead and type that into the calculator. And so the square root of 20, you'll have to see how many decimal points you want, but the square root of 20 is about 4.47 units are in miles. So the recycling center and the school are about 4.47 or maybe 4.5 miles apart. Okay, that concludes this video over midpoint and distance. If you have any comments or questions, I encourage you to leave them down below and I'll get to them as soon as I can. If you found this video helpful, I would encourage you to give the video a thumbs up to support the channel. As always, I thank you for watching this video, and I'll see you in the next one.